Aaron is probably the world's only robot artist. It was made by Harold Cohen, the leading British abstract painter. Cohen's been working on Aaron since the late 60s. The program which plans or devises the pictures contains as much code or text as a medium-sized novel. But is Aaron simply regurgitating Cohen's own painting from its memory?
It's a genuinely generative package in the sense that the drawing didn't exist 5 minutes ago. Every drawing it does is a unique image that has never been seen before. If you see it making two figures instead of one figure, that's because it decided to do that. If it makes one person facing out of the painting, that's because it decided to do that. All of those decisions, everything you see on the canvas is the result of whatever it was that the program did.
Aaron is probably unique in generating original paintings, but computers are in widespread use throughout the arts today. And there are real contributions that artists can make to the field of computing and software development.
What's very important about what we do here is that we're oriented towards live performance. There are modes of thinking that are very special to different disciplines. And I would say that not every mode of cognition is easy to capture in a computer language. I think we have to look to the arts and see how these modes of cognition can influence the design of machines that will, in some sense, respond to human need and human expression. It seems natural to me that there would be a payoff in doing this.
But what could artists gain working with computers? Do computers constrain rather than enhance performances? Can computers ever operate fast enough to keep up with the intricacy of a live event? And doesn't the need to program restrict the way an artist can think about their work? But there have been many changes in the field of computing. Changes in the speed of machines, their programming languages, their ease of use, and their responsiveness.
This really marks the end of the first phase. The program's been manipulating closed forms, adding some open forms, crisscrosses, comb-like shapes, parallel lines, and things like that.
One aspect of software development that has changed for everyone, artist or otherwise, is the speed at which computer programs can be run and tested. In the early days, Aaron's program only defined rules about how to generate simple shapes. The system could produce abstract pictures, all composed of just lines and squiggles. But in the 60s, writing even the simplest of Aaron's line-drawing programs was a laborious process.
You had to type each single statement in a program on an IBM card, making sure that it was syntactically correct. Had to be extremely careful to make sure that you didn't get the cards mixed up, because if you did, obviously all hell would break loose if you tried to run the thing. And then literally you took all this bunch of cards and you put them all in a tray and you handed them over the counter to the operator, who would say, come back tomorrow. That's how you got stuff into a computer. Simply to debug, a 25-line program, it might very easily take you 3 days. So it's a very long and tedious business.
And Cohen wasn't alone in finding programming a frustrating and slow process during the 60s.
Well, it was just a big waiting game. I remember very much spending several nights computing on the main campus computer and preparing this tape, sending it off and getting back a tape silence. And I found that I made a mistake in my program and multiplied everything by 0 at the end.
With Aaron, Harold is trying to see if it's possible to describe in code some aspects of the process of painting. George Lewis, on the other hand, is interested in the process of musical improvisation. His music is new and for many difficult to follow, but he spent the last 30 years working with computers, exploring the possibilities of computers improvising with him. During the 70s, artists like George Lewis found they really couldn't play the programmer's waiting game any longer.
At the time, a lot of people that were doing interactive music discovered that you needed to have interactivity at every level of the process of creating a computer program, from the performance right on through the construction of the program. And so you kind of needed to speak with the computer. You kind of needed to have feedback. And a lot of languages didn't provide that. I mean, if you play the trombone, you know, that's pretty interactive. I get a sense of I'm communicating with the instrument in some respect.
George Lewis's software, written in a language called Forth, contains thousands of rules. The rules determine the way the system should play. It listens to how George is playing and then actively improvises with him. As with Aaron, there's a lot of complex code defining these rules. The program has taken years to develop, and for George, the flexibility of Forth, with its interactive development environment, was a major breakthrough even for the most simple task.
A lot of people use Forth because it was pretty syntactically simple. It ran on small machines, and it didn't cost anything. So that essentially, if you wanted to make something in Forth, I start a word like, I'd say middle C, and then I just play a note. That's pretty good. So I'd say, well, let's say middle C, that sounds really good. Maybe I'll make a D too, okay? Then I'll make an E while I'm at it. So let's say 64. That's a little melody there. That's pretty good. So I kind of like that melody. So what I'll do is I'll just give it a name, and we'll just paste all that stuff in and hit return. Bang. Okay, and then we play that note. After that was really the thing, that you could work really quickly. You could improvise the things you wanted to play and then write improvisation directly into a program. That's pretty useful.
So one important change over the last 20 years is the arrival of these new interactive programming environments. Interactivity has allowed all users, artists or otherwise, a better chance to see or hear immediately the outcome of their programs. Another equally important change has been in how users could express their ideas more naturally or conveniently, more on their own terms rather than the computer's.
Yeah, here's a case in point. All of these shapes have been produced really from the program just making sort of scribbles rather the way a little child might, then drawing a line around them. And it comes up with a much richer set of forms. I had to teach it to write its own name because it was in the American Pavilion of the World Fair in Japan, and I wasn't going to be there, so it had to sign its own name. Never learned to write very well.
Aaron's early drawings were composed of simple lines, curves and squiggles. To make these images, Cohen needed a program which could express rules about the mathematical properties of shapes. He needed a language which was good at defining how to form curves and connect straight lines. However, Cohen now needed Aaron to move on.
If the program was really going to act like it knew about the outside world, I better tell it something about the outside world. And then that brought us to these, what you might think of as the first figurative things, in which you can clearly recognize people, structures and trees and rocks and things of that sort.
To do this, Aaron now needed a computer language which could capture more abstract ideas about people, faces and plants. During the 70s, there was a growing range of programming languages to choose from. Aaron's old language, C, which dealt primarily with mathematical calculations, gave way to the common LISP object system, which allowed Cohen to express far more abstract ideas.
I was writing in C for a very long time, and C is a very powerful language for doing certain kinds of things. But I was beginning to sense that it was preventing me from thinking about the things I wanted to think about. And finally changed over because it was becoming apparent to me that C was not capable of expressing abstractions in a powerful enough fashion. And I switched over to Lisp and found, wow, it's suddenly like the sun shining.
With Lisp, Cohen could now easily express ideas or rules about how to paint people, plants, and even faces.
Knows about human beings, which involves knowledge about how they move around, how they're constructed, what kind of range of proportion they can have, particularly about the face. A great deal of information about how the face can be formed and how wide the eyes can be apart and so on. It thinks of a plant as being a branching structure, and the things it can manipulate is when it branches, is it simply bifurcating? How many limbs can come out at any one juncture? How many levels of branching there are? What kind of leaves it sticks on the end, and so on. And in the same way that it generates plants by manipulating those parameters, it can also generate a new human being by manipulating all the things, all the proportional things it knows about in the face.
I think one of the complaints people had all along about working with this medium was that they couldn't let their intuitions work very well, and they didn't have an idea of what to do. They couldn't speculate in an intuitive manner unless they had a good grip of what how the materials would behave. But I think now we've moved to a time when we can use the computer, in fact, to present information about the material in such a way that the intuition can work.
Today, there's a bewildering range of languages to choose from. Programmers can make a genuine choice depending on what they're trying to do. The composer Stephen Pope has chosen a language called Smalltalk in his music composition and production system. Pope can play a piece of music and then display it at different levels of complexity.
Now, if we record that into the computer, being as this is in Smalltalk, everything gets represented as objects, from the very lowest level musical notes and properties of musical notes, such as their pitch or their start time, all the way up to an entire musical composition, which is what we call an eventless object. Everything obeys this uniform representation of objects that have state and behavior. This particular note starts at time 9300 milliseconds, and the note has properties such as its duration, its pitch, its loudness. These are the objects and their attributes. If I wanted to pick out the rhythmic structure of the Bach fugue theme, I could, for example, use what I call a time sequence view, which is a very simple rhythmic view. To execute this, I just select the text and then use the Smalltalk menu item, do it. Here we see the rhythm of the fugue theme. Many music representations allow you to work at the note level. For me, that's sort of the lowest level. As a composer, you normally think at a higher level. Chords, chord progressions, repeating ostinato patterns. Mode has a framework of objects and classes for representing these middle-level musical structures. One example of that is what I call a dynamic cloud. It's a semi-random way of describing a set of notes where you give the contour. What we have here is a very simple description of a cloud that starts in a fairly wide range and then focuses onto a single note. Now this is an object, this dynamic cloud, and I can send it the message, play yourself.
High-level languages like Smalltalk allow artists to express their ideas in a more natural, less computer-oriented way, providing them with a powerful set of building blocks.
Well, the building block metaphor is useful to a certain degree in comparing high-level and low-level programming languages. The analogy being a low-level programming language gives you all of the tools and basic components you need, and you could build a church just starting with nails and pieces of wood. In a high-level language, the analogy would say that you start with higher-level, more complex prefabricated components, such as window frames, door frames, arches. Now, assuming that you can customize these very easily, this would allow you then to focus much more on your architectural goals in building the cathedral. For a programmer working in the arts, it means that he or she can spend much more effort focusing on artistic issues rather than on the low-level programming issues of expressing their domain in terms that the computer can easily understand.
For Harold Cohen and Stephen Pope, the 1780s saw the arrival of high-level programming languages like Lisp and Smalltalk. Increasingly, they could express themselves on their own terms, rather than the computer's. But there could be problems with these high-level languages.
One of the trade-offs in high-level versus low-level languages is always going to be performance. There will always be a performance advantage in you taking the time to express your programs in a computer-like language, a low-level language, versus writing in a very high-level simulation language or an object-oriented language where the computer does the translation and potentially doesn't do it as optimally as you might if you were a computer expert.
Cohen is interested in defining how Aaron works, not in how fast. In fact, it may take Aaron all night to complete a painting. However, for some artists, the speed of the final performance is vital. George Lewis has had to avoid some high-level language simply because they couldn't perform fast enough. For Lewis, real-time performance has always been vital.
In terms of real time, yes, you do want it to happen right away, but music really is in real time in the sense that you can't speed ahead to the end. Like at a certain point, maybe say Aaron won't take a day because it has some super fast machine that will do everything right away. But in this process, the only way to hear the piece is to experience it. There's really no other way. You can't speed it up. It's real time, real world situation. So improvisation is really intimately connected with that.
And then really is characteristic of the kind of drawing it can do once it has that fully three-dimensional knowledge base. This was one of the first attempts to have the machine do its own coloring. The drawing was produced on the painting machine, and it then proceeded to start coloring the thing. I think at that point it dropped a brush or dropped a cup or whatever, and this one was abandoned.
Aaron's abilities reside in thousands of lines of Lisp code. Although it's a high-level language, Lisp still has a complex grammar or syntax for how these lines of code can be put together. Harold's notes in the margin are just translations of the code's meaning. Many artists have learned complex formalisms for expressing their ideas, but not everyone is so keen to learn a new one just to control a computer. The late 80s and early 90s saw the arrival of graphical language, which helped new users enter the world of programming without even knowing it.
I don't know. It's somewhere behind the objects. Some genius computer programmer did all the works for me, and I'm coming and I'm just picking up the object that I need. I have no idea what's behind it. I'm a composer in the traditional way of it, writing on paper, and I came with no background in computers, and it was relatively easy. I know that there are tons of words, syntax, signs, symbols that I have no idea about it. I don't understand it. The only thing I know is if I'll take an object name table, it will bring me a table and I can then edit it. That's all.
Eytan Steinberg entered the world of computer music through a graphical programming language called MAX, developed in the late 80s by Puckett.
I think that by the time users of MAX are doing complicated things, they realize that they're actually writing a computer program. At the beginning, it has more the complexity of a spreadsheet system or something like that that allows you to do things, to connect things, but doesn't feel like you're programming. But the fact is that it is powerful enough to invite program it, and people usually do respond to that invitation sooner or later. Is intended to be much easier to learn than a typical programming language like C or LISP or Smalltalk. And I think it actually is a lot easier to learn than C. I had to learn MAX and I had to learn C. And actually, I felt pretty much near the same difficult test because I had to invent MAX while I was learning to use it. But I think that when you watch a musician start to program using MAX, usually within a month, they're up to full speed and ready to realize their ideas. One way of saying it is that MAX is really a way of fooling composers into programming computers. It's a programming language that tries not to look or act like a programming language.
Again, as a high-level language, MAX allows users to express their ideas on their own terms.
This is much simpler. The traditional computer list is already behind the object. But what we see is only the upper level of it. So we don't actually, those that use MAX, we don't bother about what's behind the word table or the word list or the word note out. But in effect, there are tons of signs there. And we don't know about it at all.
But it's not just that computing offers the arts a new tool. Artists are also pushing the frontiers of computing. For Cohen, programming has never been about optimizing or automating the performance of a simple system. Programming helps him to test his understanding of an open-ended, ill-defined, and complex problem. What does a computer program need to know to create a painting?
A program is like the embodiment of a theory. You're able to make assertions about the way you think things are in the world, whatever it happens to be. You encode those assertions into a program, you run the program and see if the program does what you anticipated it was going to do. If it does, it doesn't mean you were right, it merely means you were plausible.
Well, I think many artistic issues aren't very well specified from a sort of design criteria point of view. One doesn't say what the work is going to be like at the onset. In fact, works of art often evolve via the process that's being used to generate them. A painter may start off with, some direction, but may in fact abandon this direction very quickly and find something, having found something in the process, and develop another feature. And I think this vague and ill-defined nature of the problem that artists face is very healthy for computing, because we want to bring computers into that activity in a way that maybe a bank payroll officer or a stock market speculator program and so on might not. They have very, very clear optimizations associated with them, but optimization in the arena of art the criteria often aren't very well specified, and I find that fascinating.
But it's not just the nature of the open-ended problems which provide a challenge for software development. The way artists want to interact with computers also pushes at the limits of the technology.
It's pretty much making the communication between me as a performer doing gestures and the end result, which is sounds which are stored in the synthesizer, and making, hopefully, musical sense. Uses the human vision and the body and the gestures. Here you can see when I move the fingers, these little sliders and objects are moving onto the screen, and it just shows that certain senses are being activated and received by the program MAX. I think one of the problems still resides in how you interact with the computer. And one of the frustrating aspects in a way is that you're dealing with machines that are extremely powerful, but you're still dealing with a stupid keyboard in most cases. So it's very interesting. It's like it's bringing everything into this very tight tunnel and then expands again. And I think it is happening more with virtual reality, or people trying to devise way of interacting with the computer and really being able to access this incredible, power that it gives you, and find a way that also makes sense as a human.
So the relationship between computing and the arts has never been one-sided. Despite first appearances, the arts have made a significant contribution and acted as a real impetus for change in computing and software development.
There's been a tendency to somehow ignore the artist as incapable or something of mastering the technology, but I don't take that position at all. I look at these struggles and the difficulties that one has in expressing themselves in this medium and say, well, why can't we? And why can't we make it work better without making it overly simple or banal in any way? I think it's a real challenge.
Do I have feelings for Erin? No,